going on, guys? In this video we are going to see an example on source transformation technique. Here the question is asking to find out the current across this 7 ohm resistance, and in order to do source transformation technique, what we have to do is we just change this one. Like when we have current source and the resistance in parallel, we can change this one into voltage source and resistance in series. And also when we have voltage source and resistance in series, we can change this into current source and resistance in parallel. We can keep doing that until we get a simple circuit. In that way we can easily solve these problems like this, right? And here that's what we are going to do, right? That's what we are going to do right here. First of all, if you look at this one, here we have 4 ohm resistance and 1 ohm resistance in series, so we can just directly add them and make it simple, right? And also to see this in usual way, when we have current source and resistance in series, to see this in usual way, I'm going to just switch this one in this side, switch the resistance in this side, so you can see that how we are going to transfer, right? And also here, if you notice, this 6 ohm and 3 ohm is in parallel, so we can just find the equivalent resistance by just simply multiplying them together and dividing by addition, 6 plus 3, and that's going to give us 18 over 9, and that's going to be equal to 2 ohm resistance. So equivalent resistance for this 6 ohm and 3 ohm is going to be 2 ohm resistance. Now let's go ahead and put that. So first we have this 5 ampere right here, and also the equivalent resistance we found out, that is 2 ohm. So we are going to have this 2 ohm right here, and then here we have this voltage source, negative plus 5 voltage, and then here we have our 7 ohm. Okay, this is our 7 ohm, and we are trying to find this current across this 7 ohm, and that's it for this one. And let's go ahead and do this one right here. So what we are going to do is we just going to add this 1 and 4 together, and that's going to be 5 ohm, and I'm going to put that thing right here. Okay, 5 ohm, and then we are going to have this current in the other side, so this is going to be just 3 ampere right here. Now let's see how we can simplify this one. And here we have, you can notice that we have current and resistance in parallel, so you can change this one into voltage and resistance in series. Now in order to do that, we have to find the voltage source. That's going to be V is equal to IR, and I is 5 times R is 2, that's going to be 10 voltage. So new voltage source is going to be 10 voltage right here, and then we are going to have this 2 ohm in series, so this is going to be 2 ohm right here, and also we have this negative plus 5 voltage, and also we have this 7 ohm right here. We have I naught going through that. Okay, and also again I'm gonna make this one into voltage and resistance in series. To do that, again I'm gonna put V is equal to IR, I is 3, R is 5, so 3 times 5 is going to be 15. So 15 voltage is going to be our voltage source, and this 5 voltage is 5 ohm is going to be in series, so this is 5 ohm right here, and then we are going to have this 15 voltage right here, so this is going to be plus minus 15 voltage, and that's it. Now if you notice, we have 10 voltage and 5 voltage in series, so we can add this voltage together and write it as 15 voltage, right? We can write 15 voltage, and we have 2 ohm, and here we have 5 ohm. Okay, let's draw our new circuit. So this is 2 ohm, and here we have 7 ohm. 7 ohm. Okay, this is going to be our 7 ohm right here, and let's draw our this thing. This is 5 ohm, and then here we have plus or minus 15 voltage, and that's it. Now if you look at this one, the only thing we can do right here is again turn them back into current and resistance in parallel. In that way we can see whether we can simplify this one furthermore, right? So you just keep going on and on and on until we get a simple circuit. So now what I'm going to do is I'm going to turn this one into current and resistance in parallel. So to do that I have to use I is equal to V over R, and here V is 15 divided by the resistance 2, that's going to give us 7.5 ampere, and that's going to be our new current source, 7.5 ampere. And after that this resistance is going to be in series, this 2 ohm is going to be in series, and middle remains the same, that's going to be just 7 ohm. I also keep track of this I naught right here. Also we have I naught, and in the other side also I'm going to do the same thing. Again I'm going to turn this one into current source and resistance in parallel. So I is going to be equal to V over R. V is 15 divided by 5, that's going to be 3 ampere right here. So new current source is going to be 3 ampere, but in between we are going to have this 5 ohm in parallel. So we are going to have this 5 ohm in parallel. Also we are going to have this current source, that is 3 ampere. Okay, this is 3 ampere, and that's it for this circuit. Now let's see what we can do from this. Again we have this 2 ohm and 5 ohm. Don't do anything with this 7 ohm because we are trying to find the current across this 7 ohm, but we can combine this 2 ohm and 5 ohm together because those two are in parallel. So to combine them together we just multiply and add them, like multiply 2 times 5 divided by 2 plus 5, and that's going to give us 10 over 7. So 10 over 7 is going to be the equivalent resistance for this 2 and 5, and we can draw our new circuit. Also I'm going to draw these currents in one side so we can see how they are going to add up, right? Also I keep this 7 ohm in the last so we don't have any problem, right? I naught. Okay, then our new equivalent resistance was 10 over 7. Okay, 10 over 7 ohm, and here we can draw our current sources. One is 7.5 ampere and the other one was 3 ampere. Okay, this is 3 ampere right here. Okay, this is 3 ampere, and from this one we can see that 7.5 and 3 ampere, both are in the same direction, so we can add them together. That's going to be 10.5 ampere, and 10.5 ampere. Our new circuit is going to look like this. So I keep like this, 7 ohm and I naught, and then we are going to have 10 over 7 ohm, and we are going to have the new current, that is 10.5 ampere. This is 10.5 ampere, right? Now let's see what we can do with this, and still we are not very simple. So to simplify this one, what we can do is we can again transfer this one into voltage resistance in series. To do that, again V is equal to IR. Here V is actually I is 10.5 times resistance is 10 over 7 times 10 over 7, and that's going to be 105 over 7. 105 over 7 is basically 15, right? Because 7 times 10, 30. 7 times 5, 35. So 70 plus 35, that's going to be 15. Okay, so 15 voltage is going to be the new voltage source we are going to have. Now I draw this circuit right here because we are lacking in space. So let's draw this circuit right here. Okay, this is our 7 ohm, and we are going to have I naught right here, and this resistance is going to be in series right now. So this is 10 over 7, and the new voltage source is going to be plus minus 15 voltage, and then that's it. Now we have simplified our circuit. Now the question was to find the current across this 7 ohm resistance. Now to find the current we have to use I is equal to V over R. I is equal to V over R total in this case, and we know that V is equal to 15 voltage, and the R total is going to be 10 over 7 plus 7 ohm, 10 over 7 plus 7 ohm, and if you find the common denominator, that's going to be 49. Okay, 7. Common denominators, we can take 7. On top we are going to have 49. 49 plus 10, that's going to be 59. So 15 over, this is equal to 15 over 59 over 7, right? And if you simplify this one and find the current, that's going to give you 1.78 ampere, and this is the value of this I naught we have. That's the question. We are trying to find this I naught, so that's the value of I naught, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.